Assalamualaikum and selamat sejahtera to Sir Huzin and Sir Zuki. Today, we will be presenting our DCN integrated mini project with embedded systems. The theme for our project is Smart Home Automation System. So our Smart Home Automation System is called C-Pintar. So C-Pintar uses IoT, Internet of Things, as a prime construction in the system because it needs an internet connection to work. So why IoT? So IoT contributes the internet connection and remote management of the mobile appliances incorporated with a variety of sensors. In our case, we use the humidity and temperature sensor. So the sensors are attached to the home-related appliances such as lights. Thus, it embeds the computer intelligence into the home device to provide ways to measure the home conditions and monitor the home appliances functionality. Cloud computing is also used in this system. It provides a scalable computing power, storage space, and applications for developing, maintaining, running home services, and accessing home devices anywhere at any time of the day. So this system provides more security, energy efficiency, low operating costs, and also convenience anywhere you go. So the installation of this product provides convenience for the consumers and also savings of time, money, and also energy. So why do we come up with C-Pintar? So basically, a prime concern for people is leaving their home without hesitation or worry that they might have the lights, left the lights being turned on. Thus, they also do not have the power to switch on and switch off the lights, and they do not have the flexibility to do that from far away. This will not only cause unnecessary staggering amount of electric bills, but it also causes electric wastage. Secondly, people are often unaware that their surrounding temperature and humidity may cause a lot of harm. High temperatures and humidity may cause formation of fungus that can cause diseases, exacerbate pre-existing chronic conditions such as various respiratory, cerebral, and cardiovascular diseases. Optimal surrounding humidity and temperature is important to ensure the maintenance of quality in some special personal collections like paintings in our homes, guitar, or clothing, and to also provide a healthy environment by maintaining good air quality to avoid dryness on eyes and skin that causes discomfort to us. So it's very, very important to know and be aware of our temperature and humidity to have an optimal lifestyle. So our problem statements are absence of the real-time monitoring for existing home systems, energy saving is not optimized to its full potential, absence of control mechanism that contributes to more energy wastage, and lastly, absence of a system that checks the temperature and humidity to be a reminder for full health and life optimization. Also, our name C-Pintar actually has a meaning to it. C actually stands for conservation, meaning conservation of energy, and also control, meaning you can control the home appliances with the help of IoT. Lastly, our objectives for C-Pintar are two objectives, which are to provide a system that monitors the temperature and humidity of the home with the aid of sensors, and also secondly, to provide the freedom of controlling the lights of your house with a touch of a finger.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Al-Fatihah Beruslan, and I will talk about IoT system architecture, which I need to specify the controllers, sensors selected, and type of combination that we use. First of all, I will talk about sensor. In this case, we are only using one sensor which we need to check the temperature of the room. The sensor that we use is temperature humidity sensor, the HD11. The accuracy for this temperature sensor is plus minus 2 degree, which optimal 0 until 50 degrees Celsius. Next point is the accuracy for humidity. The accuracy for humidity is only 5% only. That's suitable for 0 until 80%. The input voltage that we can use for humidity temperature sensor is 3 until 5 volt, and the maximum current that we can only using this is 2.5 milliampere. As you can see here, the safety rate for this sensor is less than 1 Hz. Next, I will talk about the controllers that we use in our integrated project. The controller that we use in our integrated project is Raspberry Pi 3B+. As you can see here, Raspberry Pi 3 Plus using ARM architecture, which is using Cortex A53 ARM V8 64-bit SoC. And the RAM for this Raspberry Pi is 1 GB SD RAM. And there are many features in Raspberry Pi, which is Wi-Fi, Ethernet, audio, and USB port. The GPIO for this Raspberry Pi contains 40 pins, and power supply that we can use is 5 volt or 2.5 volt, and the current that we can use is 2.5 ampere DC power input. The operating system that support this Raspberry Pi is Linux and Unix. Next, I will talk about the application that we use in our integrated project. The application that we use in our integrated project, when we light up the bulb or LEDs or check the temperature in our room, we are using Blink. So what is Blink? Blink was designed for the Internet of Things. It can control hardware remotely, it can display sensor data, it can store data, visualize it, and do many other cool things. So we are using Blink apps. What is the Blink apps? It allows us to create amazing interface for our project using various widgets we product. Lastly, we are using cloud service. As you can see, we are using ThinkSpace. Why is ThinkSpace? ThinkSpace is allow us to aggregate, visualize, and analyze live data streams in the cloud. So mostly, as you can see here, ThinkSpace are using MATLAB to make sense of our IoT data. So as you know, the data that we have from our sensor, we are gathered and send it to the cloud service, which is ThinkSpace. Lastly, I will talk about type of communication that we use in our integrated project, which is wireless fidelity, which is Wi-Fi. Wi-Fi is a family of wireless networking technologies. The standard of the Wi-Fi is IEEE 802.11 standards that are commonly used for local area networking, LAN of devices, and internet access. Wi-Fi is a trademark of the non-profit Wi-Fi Alliance, which restricts the use of the term Wi-Fi certified to products that successfully complete interoperability certification testing. So, what is the advantage by using Wi-Fi? Wi-Fi gives us a freedom, which can work from any location that we can get a signal. Second point, the setup cost of the Wi-Fi. Wi-Fi does not need any cabling required, so it will save our cost. Furthermore, the flexibility. Wi-Fi gives us quick and easy to set up in temporary or permanent space. Lastly, I will talk about the communication issues that face from the Wi-Fi. There are three or four communication issues that face from a Wi-Fi, which is reliability, security, installation problems, and transmission speeds. Firstly, the reliability of the Wi-Fi. Like any radio frequency transmission, wireless networking signals are subject to a wide variety of interference, as well as some complex propagation effects that are beyond the control of the network administrator. The next point for communication issues that face for Wi-Fi is security. Wi-Fi is more likely to expose to attack by unauthorized users. To encounter this problem, Wi-Fi may choose to utilize some of the various encryption technologies available. The most commonly used for Wi-Fi is wired encryption privacy or wired encryption protocol, which is WEP. So what is WEP? So WEP is secure our wireless network with an authentication protocol, which which mean by we have a password, we need to enter the password so the unauthorized user can use our Wi-Fi. The advantage of the WEP is easy to configure and widely supported security system. The next issue is the installation problem that we encounter for our Wi-Fi. So we may have experienced interference with others in the same building who also use wireless technology, or where other sources of electromagnetic radio interference exist. This give us disadvantage, which we have a complete loss of wireless connection and it interrupt our system. Lastly is the transmission speed. So the transmission speed we encounter from the current
broken and wasted. I spend my life chasing the questions and answers to love, life, and cancer. I can't go much longer. I wish I was stronger to hold back.
compared to Wi-Fi, internet connection possess superior stability and reliability. Wi-Fi signals are transmitted via radio frequencies and are prone to disruption. The control and security offered by Internet are difficult to match. Wi-Fi connections are generally prone to a wider array of potential threats. So basically, Internet using a cable which is in twisted pair, and the bandwidth of the Internet is greater than a Wi-Fi, so there is no propagation delay rather than Wi-Fi. So thank you. That's all from me.
Hello, today I will do the demonstration for smart home system. So today our circuit has been connected to the Raspberry Pi, and then here is the dashboard for our interface using Blink, which also there's a graph there, two buttons for small room and master room, and also the value display for humidity and temperature, and also for the email notification and Blink notification. So today I will be using this laptop, which is not connected to the Raspberry Pi, and then I will launch the code here, or make the connection through here. Let's do it. And also another computer I'm using, which I'm connecting I'm showing the ThinkSpeaks using the regular Wi-Fi, regular internet connection. As you can see, the sensor started to detecting the humidity and temperature. So the value at ThinkSpeak also should be correspond to the value of the sensor. See, there's changes done at the graph, which following the temperature, which detect the temperature and the humidity. So now I will demonstrate how the control element will be functioning. So from the Blink apps, I will controlling this small house lamp. So the first one, small lamp, the small room. Oh my god, sorry. I'm gonna start it. Start. Okay, small room. Oops, notification. Temperature shows when this notification is sent, it's mean the sensor detecting temperature above 28, above or equal to 28 degrees Celsius. And now I will turn on the light for master bedroom. Yeah, there you go. And also, as you can see here, Blink also send the notification through the email, which are already being sent. Yeah. Again, and the sensor actually, this Blink app is set to send the notification every 15 seconds. Yeah, 15 to 30 seconds. Yes. I think that's all from me. And yeah. So for the result analysis, the first one, we successfully do the event triggering for Blink app, which is the Blink will send the notifications to the user through the app if the temperature detected is equal or above 28 degrees Celsius. So for the second result that we successfully obtained from this project is regarding the control element. So we successfully can control the two LEDs which connected to the Raspberry Pi on the GPIO 5 and 6 by only using by only just pressing the two button on the Blink dashboard that we already created. By looking at the graph here, the temperature data is stated within a small room, and the DST11, the sensor, the temperature and humidity sensor, the data captured by the sensor is only between 27 to 28 degrees Celsius. And then for the average temperature calculated is about 27.6 degrees Celsius. And the median collected here or calculated is about 28 degrees Celsius. And just for extra information, an ideal room temperature is usually between 26 to 27 degrees Celsius. Now from the graph, the highest frequency for the room temperature is 28. So since the highest frequency is 28 degrees Celsius, which meaning here the sensor will be sending the notification through email and Blink apps every 30 seconds if there is a temperature constantly at 28 degrees Celsius. Now let's move on to humidity output result analysis. Okay, as you know just now, as I said, ThinkSpeak can only update a new channel every 15 seconds. So for data, for humidity data, also is tested in the same room as the temperature, and the range of humidity data captured by the sensor is between 40 to 58%. The average humidity calculated is about 48.8%, and the median for humidity data collected is 47%. And just for your extra information, an ideal room humidity level is about 40 to 50%. I think that's all from me for the result analysis. Thank you.
Although our C-Pintar is very, very reliable, we also have certain communication issues. So The C-Pintar is a device that uses Wi-Fi and the internet to its full potential. Although Wi-Fi is widely and commonly available, the full potential of this device may be potentially disrupted with some communication issues, such as the first communication issue is reliability. So like any other radio frequency transmission, wireless networking signals are subject to a wide variety of interference, as well as a complex propagation effects that are beyond the control of the network and administrator. The second communication issue is security. So, wireless transmission is more exposed to be attacked by unauthorized users. To combat this consideration, wireless networks may choose to utilize some of the various encryption technologies available. Some of the more commonly utilized encryption methods is Wired Encryption Privacy or Wired Encryption Protocol, WEP. Third communication issue is installation problems. So we may experience interference with others in the same building who also use wireless technology, or where other sources of electromagnetic interference exist. So this could lead to poor communication, or in extreme cases, complete loss of the wireless communication itself. So this will interrupt with the system. Last communication issue is transmission speed. So wireless transmission can be slower and less efficient than wired networks. In larger wireless networking systems, the backbone network is usually wired or fiber rather than wireless. So this will lead to transmission delay. So to counter the problem, we may use Ethernet. So Ethernet, compared to Wi-Fi, possesses superior stability and reliability. So Wi-Fi signals are transmitted via radio frequencies, and this may cause they are prone to disruptions. The control and security offered by Ethernet are difficult to match. So Wi-Fi are generally more prone to a wider array of potential threats compared to Ethernet. Conclusively, the project was conducted to provide a real-time monitoring for existing home systems, providing ease and a worry-free feeling to the users. So this project was also created to maximize energy saving to its full potential and to create a system that checks the temperature and humidity to be a reminder for full health and life optimization for the users. The project activities were carried out by finding the suitable sensors and boards to accommodate the requirements of the project. Next, we searched for the code online and altered the code to fit our problem statements. Thus, we did the improvisation on the device and the code to the device and the code. And lastly, we monitored the data of the device. Thank you so much.